Okay, let's see. What do we have? We started with when you have a matrix A, so we can multiply this matrix by a product of elementary matrices E, so that the resulting matrix is, so this is a product of, in general, given a matrix A, we can multiply it by product of elementary matrices, product of elementary matrices, and the result is either the echelon form or row reduced echelon form, the row reduced echelon matrix. So we can write it like this. So let's see. Let me give one example before giving the definitions. Let's look at this matrix A. A is, let's take as 2, 1, 3, 5, for example. Okay. Maybe. Whose microphone is open? Somebody's microphone is open. Can you, yeah, turn off, please. Okay, let's look at this matrix. Let's look at this matrix. And when you take, maybe, okay, 2, 1, 5, 3, when you write the identity matrix here, let's divide the first row by 2. What do we get? 1, 1 over 2, and 1 over 2, 0, 5, 3. Or let me, instead of doing that, instead of playing with this fractions, instead of rational numbers, just let me do it another way. Okay, let's do it. This is, you can do it this way, but the easier way is perhaps is that you multiply, for example, first row by -2 and add it to second row. Then you have 2, 1. So let's do it like this: 2, 1, 1, 0. And when you multiply by -2 and add it here, you get 1, 1, 1, -2, 1. Right? You multiply the first row by -2 and add the second row, and then interchange row 1 and row 2. Row 1 and row 2, which is 1, 1, -2, 1, and 2, 1, 1, 0. And then you multiply by -2 row 1 and add to row 2, so that this 2 becomes 0. 1, 1, -2, 1. If you multiply by -2 and add here, -2 plus 1 is -1. This is 4, 5, right? -2. Okay. Next, what do we have? Let's add row 2 to row 1, so that this 1 becomes 0. It's 1, 0, 3, -1, 0, -1, 5, -2. And let's multiply the second row by -1. You get 1, 0, 0, 1, and 3, -1, -5, +2. Okay, we have this matrix. So the matrix identity, this is R, right? That's R, is the product of these matrices 3, -1, -5, and 2 times identity. It's 2, 5, 1, 3. So you can really check it that it's true. Let's multiply it. Well, let's say if you multiply this 3 times 2 plus -5 is 1 and 0. So this is really this 1, 0 and 0, 1. It's really the identity matrix. So this is the matrix A. This is the matrix A, and this is the matrix E. So that E times A is identity matrix. So A is a square matrix. You can also check. That A times E is also identity. And here's a definition for this. This is very useful. So when we have a square matrix, so here in this example, we had the square matrix A, and by applying row operations, we get the identity matrix. We got the identity matrix here. Identity matrix. So that and we have another matrix E, not that one here. Sorry. Yeah, that's E. Sorry, that's E. So when we multiply this E by A, we get the identity matrix from both sides. I mean, we can check only, we checked only from when we multiply from the left-hand side, but also true from the right-hand side like this. So here's the definition. A square matrix or it need not be a square matrix, let's say. Maybe with this, for this definition, you need not a square matrix. A matrix, let's say B is called the left inverse of a matrix A if B times A is the identity matrix. Identity matrix of some size, whatever size is not important. Of course, if A is a square matrix, then B is a square matrix of n by n, then I should be n by n matrix. That's left inverse. And also, there's also right inverse. If A times B is equal to, then B is called a right inverse. This is not that. This is A left inverse, a right inverse. And if A is a square matrix, A and B are square matrices, are n by n matrices. And if A times B is equal to B times A, which is the identity, then B is called the inverse of A and denoted by the inverse. So for the A inverse, it has no other meaning. Like in calculus, for example, when you write sine inverse x, it might mean two things. For example, it may mean sine 1 over sine x, or arcsine x. So usually the books uses this notation, but I don't prefer to use this notation. The reason is that it may be confusing with this 1 over sine x, but because if we have 3 to the minus 1, it is just 1 over 3. But here, if we have a matrix A, then 1 over A has no meaning, so that A to the minus 1 is meaningful. A to the minus 1 represents the inverse of A. So that A inverse times A is equal to A times A inverse is identity. In the above example, what was A? A is 2, 1, 2, 1, 5, 1, right? 5, 3, sorry. Its inverse is, so this is A, its inverse is the matrix 3, 1, minus 5, 2. 3, 1, minus 5, 2. So let's check this. 3, if you 1 minus 5, 2, if you multiply this matrix from the left-hand side by A, there's some minus 1 somewhere. Something is 3 minus 1. Yeah, here minus 1. Yes, if you multiply this, it is 1, right? 0 minus 10 plus 10 is 0. Minus 5 plus 6 is 1. And let's check from the other side. 2, 1, 5, 3. Once you find it, you need to check it, that it's really the inverse, minus 5, 2. So when you multiply from this side, 6 minus 5 is 1. Minus 2 plus 2 is 0. 15 minus 15 is 0. Minus 5 plus 6 is 1. So therefore, these matrices are inverse of each other. Okay. Let's see. Minus 1. Yes. Okay. So let me give another example. Well, not every matrix is invertible, of course. I will write one matrix, but I don't know if it is invertible or not, but let's check it. If it is not invertible, then we will get into trouble. Let's look at A is, let's take 3 by 3 matrix. 3 by 3 matrix. Let's put lots of zeros. 1, 0, minus 1, 2, 1, 0, 0, 1, 3, minus 2, for example. Okay. So let's check whether this is invertible, and if it is so, let's find it is its inverse. Of course, if A is invertible, if the row reduced form, form of, or row reduced echelon matrix of A, row reduced echelon matrix. What happened? Row reduced. Of A is identity, then I3, then A is invertible. And we will find it. Let's try to find it. How do we start? 1, 0, minus 1, 2, 1, 0, 0, 1, minus 2. Namely, we will write this A as a product of elementary matrices. And product of those elementary matrices will be the inverse of A. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So what do we do first? row -2 times row 1 plus row 2 makes this 2 0, 1 0 minus 1, 1 0 0. And you multiply by -2 and add here 0, 1, -2, -2, 1 0. And the rest is the same, 1, 1 -2 0 0 1. As you see, we got this second row, and third row is the same. So that's a good example, actually. And if you add minus R2 plus R3, efendim?
Second row to third column, -2 is +2.
+2. Let's see. Yes, +2. Okay. Right. Good. Otherwise, it will. Otherwise, it is. If it is -2 here, then it is not invertible actually, because row reduced echelon matrix will not be the identity matrix. Okay. So after this example, let's change it that way so that we will see it. Okay. Let's see. Thank you. Let's multiply the second row by -1, add it to the last row. It is 1 0 -1, 1 0 0, 0 1 plus 2, -2 1 0. Now we multiply the second row by -1, add it to last row, then 0 0 -4, right? Yes, I guess right. 4 -1 1. So if you see some mistake at some point, just say it. Good. Now what do? We want to make this entry. So these entries 0, -1 and 2 is 0. So well, if I multiply, for example, I can make this 2 0 by using the first row. So I can multiply the first row by 2 and add it to the second row, but then this 0 will change. The first entry 0 will change. So I don't want to. I cannot do that. I don't want to do that. So instead, I will use the row 3 to make these entries 0. So for this, let's divide row 3 by -4. Row 3. So 1. Efendim?
Third row, fourth column, isn't it 2?
Third row.
Third row, fourth column. Isn't it just 2?
This is, you mean this one?
Yes.
Let's see. You multiply it by -2 and add here. -1. You multiply by -1, right?
Yes.
-1, 2, -1, -1. Yes. You're right. Oh, thank you.
Okay, thanks.
Okay. 0 -1, 1 0 0, 0 0 0 1. Sorry, not 0. 0 1, 0 1 2, -2 1 0. If we divide by -4, this becomes 1. This becomes minus. Let me write like -2/4. It is -1/2, but let me write this way, so that all the denominators are the same. So this is 1/4 -1/4. Okay. Now add the last row. So instead of row 1, you write row 3 plus row 1. So that this becomes 1 0 0, this becomes 2/4, 1/4 minus 1/4, and 0, 1, 2, minus 2, 1, 0, 0, 0, 1, minus 2/4, 1/4, minus 1/4. So I don't want to write 1/2 for 2/4. The reason is clear that I can make these additions easier. Now let's make this 2, 0. Let's change this to 2 to 0. For this, you multiply the last row by minus 2, and add it to row 2. Then you have 0, 0, 1, 0, 0, 0, 2/4, 1/4, minus 1/4, 0 times minus 2, and add 0, 0. 0 times minus 2 plus 1 is 1. 0 times minus 2 times 1 is minus 2 plus 2 is 0. That was our purpose. And if you multiply this guy by minus 2, the last row by minus 2, and add it to 2, what do we get? Minus 1, right? So this is plus 1, minus 2 is minus 1. Is it correct? I guess it is. This is minus 1 minus 2/4 is 2/4. And you multiply this minus, it is 2/4 here again. You multiply this by minus 2 and add it upstairs. Yes. And the last row, it stays the same. Minus 2/4, 1/4, minus 1/4. So therefore, this is the row reduced echelon matrix, which is the identity 1, 0, 0, 0, 1, 0, 0, 0, 1. And the matrix here we get is the product of elementary matrices, 2/4. Let me write like this. Oops. Let me put 1/4 outside. It is 2, 1, minus 1, minus 4, 2, 2, minus 2, 1, minus 1, times right A. What's A? A is 1, 0, minus 1, 1, 0, minus 1, 2, 1, 0, 0, 1, minus 2. Okay, so that this is A. I hope everything is correct. You can check it. So that A inverse is this matrix. 1/4 times 2, 1, minus 1, minus 4, 2, 2, minus 2, 1, minus 1. So from a square matrix, when you obtain this row reduced echelon matrix as the identity matrix, the matrix you find here becomes the inverse of that matrix, because this identity matrix, this is R is equal to, this is E times A, right? Efendim? I guess that was a mistake. Okay, so given a matrix A, you can find it is inverse like this. If the inverse may not exist, of course. Later we will see when this inverse exists or not. Okay, so here is an example. So lemma, let's say, fact, elementary matrices. Oh, before this, let me say, before this, I want to say one more thing. Suppose A and B are invertible. Invertible, I mean A times A inverse times A is identity, and B times B inverse A exists. Suppose. Then A times B is invertible, and its inverse is B inverse times A inverse. So why this is true? So let's write this as a lemma. Why this is true? You can show it like this, or example solution. In order to show that the inverse of AB is B inverse A inverse, you just multiply B inverse A inverse. If you multiply this by AB, this should be identity, and we should multiply from the other side. This is B inverse. This A inverse times A. This is identity matrix times B. Since and then the identity matrix becomes it does not affect anything. So that this B inverse times B is identity. Also, when you multiply from the other side, it is A times B inverse times B is identity times A inverse, which is A times A inverse, which is identity. So therefore, A times B is invertible because it has an inverse, and its inverse is the matrix we have here. Okay, that's the first of that matrix. Now we can use this, and in general, if A1, A2, AK are invertible. So we did it for 2, but it is true for more matrices. If you have more matrices, then it is still true. Then if this product is invertible, if each of them is invertible, then A1, A2, AK, the product is invertible, and its inverse is just AK inverse, AK minus 1 inverse, A2 inverse times A1 inverse. This has something to do with the elementary matrices. So if you look at elementary matrices, so if we have, let's say epsilon, suppose epsilon 1 is this operation, C times rho 1, rho I plus rho j. Then when we apply the corresponding elementary matrix is, so you have this identity matrix as 1, 0, 0, 0, 1, 0, etc. And at the end, so 0, 0, at the end 1, you have 1, this matrix. and you multiply the ith row by C and add it to jth row. So this is, let's say, this is row 1. So this is row 1. This is row 1, row 2, and nth row. And it is row 1, row I, and C times row I plus row J. Instead of J row, we have this row N. This is, let's say, N by N matrix. Now, if you do the inverse operation, let's epsilon 1 inverse is multiplication by minus C, multiplication of the ith row by C, and add it to the jth row. And if you, so this matrix is R1, Ri, minus C times Rj, Ri plus Rj, and etc. Rn. So this matrix, so that when you apply epsilon, an operation epsilon 1 and then epsilon inverse, it's inverse, you get identity matrix, which is the epsilon 1 inverse identity, then epsilon 1 identity. So this elementary matrix is invertible. So this is an example, so that every elementary matrix is invertible. Every elementary matrix is invertible. Okay, every elementary matrix is invertible. We wrote that given at the beginning of last lecture today, given a matrix I, A, we found there exist elementary matrices. There exists a product of elementary matrices. Let's say, let me write like this, or elementary matrices. EK, E2, E1, such that the product, this is simply just E. This is simply E. The product is row reduced, as we did above. Now, this elementary matrix, each elementary matrix is so this each elementary matrix, this is invertible. Is invertible. The reason is that each one of these is invertible, so that each one of E1, E2, EK is invertible, so that A is invertible. So therefore, what do we have is that, so that we given a matrix A, there is an invertible matrix E, such that their product is mikrofonu kapatır mısınız arkadaş? The result is the given matrix A, there is an invertible matrix E, such that the result is their product is the row reduced echelon matrix. Okay, good. Any questions so far? So let's give one example, one more example. I will give example of matrix will be small size because otherwise it will be long. Let's start from the beginning. Let's find these. And let's show that this E is also invertible. So on an example, let's take A to be 1, 2, 3. And what else? -2, 1, or 0, 1. For example, like this. So arbitrary matrix. Then, so what do we do? So let's start with A is 2, so 1, 2, 1, 2, 3, -2, 0, 1. This is not a square matrix, so that it is not invertible. Only square matrices are invertible, of course. Others are not. So let's put the identity matrix here. If you multiply row 1 by 2 and add it to the second row, you have 1, 2, 3, 0, 4, 7, 1, 0, 2, 1. So in the second entry, the matrix will be product of elementary matrices. Then divide the second row by 4. 1. So here I want to get row reduced matrix. Row reduced echelon matrix. 1, 2, 3, 1, 0. When you divide by 4, 0, 1, 7 over 4, 2 over 4, 1 over 4. So that the leading entry is 1. And multiply the second row by -2 and edit the first row. Our aim is to make this entry 0 so that we have a row reduced echelon matrix. And these ones, this one and that one, are leading entries. So let's multiply by -3 and add there. So the second row is the same. And when you multiply, bunlar kaça geldi acaba? Hey! Tamam,
çekip gitme, bıraktım sarılayım ayaklarına, kum gibi.
Kim bu? Büyüyünce Elon Musk olacak olan kim? Hep ders olmaz, biraz şarkı dinleyelim. Olur. Sen nereden geldin ki?
Hocam isterseniz hem atın, attıktan sonra şifreyi değiştirin.
Attım. Gene geliyor mu? Dur, bir daha olursa şey yaparım.
Hocam şifre aynıysa gelir. Şifreyi değiştirin isterseniz.
Bir daha bir deneyelim bakalım. Bir şey çaresine bakarız o zaman, bir daha olursa. Arada sabot etmek için Okay. Multiply by -2 and add it to 3. So it is 3 minus 14/4. What is it? -5/4, right? 1 minus konsantrasyonum kayboldu.
Hocam -1/2 olması gerekiyor.
Neresi? Burası mı?
Evet.
No, it is -1 minus -2 times 2/4 is 0, right? Isn't that true?
Ve -5/4 kısmı olması gerekiyor. 1/2.
-5/4. Ha. 4, 2/4. Ya doğru, şurası mı? Şöyle mi? Yes. 4, 3'ün 12.
Onun altında 7/4 galiba hocam. Ufak bir dikkat hatası olmuş.
Ne olmuş? 4. Şeyden sonra, şarkı dinledikten sonra şey bozuldu. Sabotajdan sonra.
Hocam bu arada bölüyorum ama 61 kişi olduk. En son attığımızda arkadaş 59'luk. Bir dikkatinizi çekerim.
Tamam. Tamam. Bir şey olursa çaresine bakarız. Gelen. Evet. Şurası ne olacak? Burası neyse artık. So -2/4. So that this is matrix E. So this matrix is invertible. 0, -2/4, 2/4, and 1/4. This is invertible, and it is 1, 0, 0, 1. Oh, sorry, not. Times identity times 1, 2, 3 minus 2, 0, 1 is the row reduced echelon matrix. And then here, we have these entries. So this is row reduced echelon matrix. This is A, and that is the E invertible matrix. Okay, let me finish here, and then let me finish recording.